All right, everyone, we're ready to get started here. It's my pleasure to introduce Mathias from Nomadic Labs, who will be going through leveraging Octez. I think if anyone has a baker running or is ever involved in anything around an upgrade, you know what Octez is. So this is going to be great. Let's give a warm welcome.
Okay, can you hear me? Yeah? Okay. So thank you for this warm welcome. I'm Mathias from Nomadic Labs, and we will talk about Octez. So first, a few words on Nomadic Labs, even if most of you probably already know us. So we are working on the core development, the evolution, and the adoption of the Tezos protocol. We are focused on Tezos. Our R&D activities are mainly focused on three subjects. First, we contribute to the Tezos economic protocol. We also build, develop, release, and maintain Octez, so an OCaml suite of tools for Tezos, but we will look this in more details just after. And we also work on Umami, Tezos desktop wallet. So before diving into Octez, let's look at the usual technology stack of blockchains. So first, you have the layer one, where you can find all the tools to run the infrastructure of the network. So nodes, storage, all the necessary tools to run the network, the consensus, the smart contract interpreter. On top of that, you will find libraries, high-level smart contract languages, developer tools, and you've seen many of them already. Even higher, you will find full dApps frameworks, and the first layer of application, I'd say, wallets, indexers. And even further, you will find dApps and higher level tools that are built on top of those, like explorers that are heavily using indexers, of course. So I'll try to use the remote. OK, so Octez is mostly consisting of tools targeting the layer one, so nodes, things like that. But we also provide some first level tooling for developers, and we will look into that a bit today. So what exactly is in Octez? In Octez, you will find a Tezos node, a client for this node, an implementation of the environment of the economic protocol. I will detail that a bit further. You will find the block producer, the Tezos baker, a remote signer, and other tools for developers, such as an encoder, decoder for Tezos data types. Before looking more into Octez, let's look at the behavior of the network and what happens when you want to emit an operation into the network. So first, you start from a client. It can be the Tezos client. It can be a wallet. It can be a dApp. And this client will send an operation to the network by being connected to a node. Here you see the blue circle, that's the operation that the client wants to emit in the network. It emits it into a node. Then the node receives the operation into its mempool. It validates the operation. Validation is a very quick check that are done to make sure that the operation can be included into a block. It's not included yet, but it can be. And if the operation is valid, the node will broadcast it to its neighbors in the network. This operation is propagated via the gossip network to all the nodes in the network. And at some point, a baker, a block producer, will take all the operations from a node and will try to bake a block. It will produce a block including this operation, and it will inject it back into a node. Then we will have the same behavior than with the operation. The node will first very quickly validate the block, make sure that the block can be applied to the current state of the ledger, and then it will broadcast it to its neighbors. This way, the block is propagated to the whole network. And while this propagation is done, the first node, will apply actually the operations included in the block to the state of the ledger, and we can say at this time that the operation has been included in the chain. In fact, with the current consensus algorithm we have in Tezos, we have to wait one more block to achieve actual finalization of this operation. And at that time, the block has been broadcast to all the network, and all the nodes will also apply its content and be in synchronization with the first one. So we've seen that To run the overall network, we have three major components: clients, nodes, and bakers, and all three we have implementations for all three in the Octez suite. So first, let's look at the Octez node. So the Octez node is really part of the layer 1. It has been designed to support the features of Tezos, and in particular to support the upgradability of Tezos. So Tezos can be upgraded via on-chain vote. Its economic protocol can be amended, and Tezos nodes must allow such upgrade. To do so, we have split the node into several parts. The first part is what we call the shell. It's the envelope that includes all the low-level parts of the node, what's necessary to handle the storage, the network communications, and things like that, and that will link itself to the economic protocol. We also have a restricted API, the protocol environment, that describes what can be accessed by the shell and what cannot from the protocol. In general, shell upgrades are not mandatory when you have an upgrade of the protocol. We only have to upgrade the shell if the protocol environment, this API that is the interface between the protocol and the shell, has changed. And this can happen if we have breaking changes in the protocol, or if we add new features in the protocol and we want to benefit from them in the shell. So Octez, the Octez node is an OCaml shell implementation that links to the economic protocol. It's released as an open source project. It has a release process that is very simple. We can release a new version of Octez anytime. It's not linked to the amendment process of the protocol. It can be upgraded to fix bugs, of course, but also to improve performance or to add new features. We had to build most of the stack from scratch, mostly to improve the performance of the node, but also to be able to support this upgrade mechanism. Of course, the Octez development teams are still working hard on it. We are constantly simplifying the code base and improving Octez, in particular the performance of the node. So, how to get Octez? It's quite simple. You go on the Octez webpage. You can download a static executable that you can run directly on your machine, it being a laptop, a server, or a very small Raspberry Pi. You can, of course, find some packages for some Linux distributions. We also provide Docker images. In the slides, you will find this black and white text. Those are links to the documentation of Octez. The slides will be published just after the talk. And I invite you to look at all those links after if you're interested. So you can find Docker images. You can also build Octez from source. There are two ways. You can use the OCaml package manager and just run opam install Tezos and let it do the building for you. Or you can build it from scratch from the Tezos GitLab repository, in particular if you want to have the latest version, development version of Octez. Look at the documentation, of course, if you want more details on all that. So you can build a node, but why would you want to run your own node? As we've seen, nodes are entry points into the network. You need them to emit transactions. They also have access to the state of the ledger, and they can be used for if you need to monitor new operations and new blocks that are propagated in the chain. They can broadcast to other nodes, and this can be a reason to use a node, but in fact, there are public nodes that are available and that are maintained by the community. So you can also use these public nodes if that's enough for you. So why would you want to run your own node if there are those public nodes? First, to mitigate the risk of connecting to a compromised node. If you want to make sure that you control the environment, all the environment of your application, if you're building an application, probably you may want to run your own node. If your application has very specific requirements, for example, if you need to have a node that is connected all the time, that includes operation very fast, don't rely on public nodes. Public nodes are shared to everyone. They can have a lot of other users that emit operations to them or that are requesting longer RPCs. So have your own node. If you want to monitor the chain is exactly the same. Probably if you want to monitor it very quickly in real time, you need your own node. In fact, if node availability is critical for you, consider using several nodes. Don't use one single node, and use node cluster. There are even some providers that can provide node clusters for you. And of course, having more nodes in the network improves decentralization and helps the overall health of the network. So we encourage you to run your own node. So once you have installed the Tezos node, the Octez node, you can run it very simply with this command, Tezos node run. You can also open an RPC server that is into the node and that is used to interact with it. So probably you will have to start the RPC server. You can configure the node if you have specific needs. In particular, you can specify the data directory for the node. You can specify the network parameters and a lot of other things. Again, and you will see this frequently in the slides, read the documentation if you want more information about this. So here I want to show you a very specific usage of the Tezos node for testing purposes. Of course, if you want to develop an application, probably you will use a DApp framework or higher level libraries and tools. And probably they will provide you some kind of tools that are in fact using the same kind of techniques that these. But if you want to use Tezos node directly, you can use what we call the sandbox mode for testing. Sandbox mode means that you can use two scripts, sandbox mode.sh and the client connected to a sandbox node. We have a script for the client too. Those will help you launch a local server, a local network, in fact, in your machine. You will launch several nodes in sandbox mode. They will connect all together locally and provide you a local network that you can use for testing. You can have so clients connected to those event bakers connected into this network. The sandbox mode comes with a pre-configured account with a lot of funds, so you can do all the testing you want. Of course, they don't have access to the state of an actual chain, a test chain, or the main chain, but you can still use them to do some transactions, to originate and call some contracts, and to test your applications locally. So we invite you to use the sandbox mode or the equivalent in your DApp framework. Of course, you can bake blocks to make the chain progress and check how your application behave in the sandbox mode. If you want to go a bit further than the sandbox mode, we encourage you to use test networks. Don't launch your application on mainnet first. Use test networks. Test networks are actual Tezos networks. They start from their own Genesis blocks. They can be used with the same Octez executable than any other network, including mainnet. You just have to specify, and we will see how the network you want to connect to. They have different names so that the node, when you're running it, won't try to talk to other networks. They can run different protocols. We will see that. They can have different constants, protocol constants. In particular, most of the test networks go faster than mainnet. The block time in the test networks is shorter. And they can change their protocol without going through the voting process to make them more easily maintainable. So test networks, why would you use them? First, to test that your application scales on a real network with many nodes, many other applications. You can check the interactions with other applications, in particular with indexers, with wallets, with explorers. You may want to make sure that your application is usable with those tools. You can ensure your system is resilient. We at Nomadic and probably others are sometimes trying to flood those test networks with many operations to make sure that they are resilient, and you can test that your application behaves correctly in such an environment. So in general, use test networks. That's important to mitigate the risk of issues in production. And and we encourage you to do it. So how would you use a test network? So it's quite simple with the Octez node. You just have to configure your node to use these test networks using this option, and you will associate this with a specific data directory. So each time you will run your Tezos node with this data directory, it will automatically connect to the test network. There are several test networks that are maintained by another company called Octez Alpha. So thanks to Octez Alpha for this. In particular, you will find a long-running testnet that is called GhostNet. GhostNet follows mainnet protocol upgrades, so that's particularly interesting for you if you want to test how your applications behave when there is a migration to a new protocol. We also provide, they also provide protocol testnets, so that's testnets dedicated to one protocol. They won't upgrade their protocol. In particular, you can find JakartaNet or KathmanduNet. And there exist periodic testnets, DailyNet and MondayNet. Those restart periodically using the latest master branch of the Tezos GitLab repository. This means that they include the latest version of Octez, even before it's released, and the current development version of the economic protocol that will probably end up being an amendment and maybe voted and activated as a new protocol in Tezos. All those testnets have dedicated faucets to fund new accounts, so you can use them to test your applications. And again, I invite you to look at the testnet webpage for more information. Okay. Here I can show you how you can run a node very quickly and synchronize it to a chain very quickly. So as you know, the chain grows continuously, and it can take very long to synchronize a node from Genesis to the current head of the chain. So to solve this issue, we propose snapshots. Snapshots are files that can be imported and exported to bootstrap the node very quickly. So here you have a small script that shows how you should start your node and have it using a snapshot. So first, you download a snapshot from a snapshot provider. There are some online that you can find quite easily. Then you run your node. Here we specify a test network, but you can use mainnet and remove all these. Of course, the snapshot is linked to the network you want to connect to. There are specific snapshots for each network. And then you import the snapshot. And once it's imported, when you will run the node, if the snapshot is not too old, the synchronization will probably be very fast. So you can join the network in a few minutes if you have a recent snapshot. We also provide some history modes for the node to allow you to decide what quantity of data you want to store on your node and the level of performance you will associate to this. So the default mode is what we call the full mode. In this mode, the node will store all the necessary data to be able to reconstruct the chain from Genesis, the whole state of the chain from Genesis. So that's the default mode. And then we have two modes, the rolling mode, that's the lightest one. In this one, the node will only maintain a minimal rolling fragment of the chain data so that the node can still validate new blocks, but it cannot replay the whole history of the chain. The size of this rolling fragment can be specified by the user. And it's probably the lightest and the easiest mode you could use if you want to run a node on a very small machine, for instance, a Raspberry Pi. Then there is the archive mode, that is the heaviest mode, that keeps all the data of the chain since Genesis. It's probably not very useful for most users and for most applications, but it's very necessary for indexer and block explorers, of course, and if you want to be able to look at what happened in the chain since Genesis. So we have this history mode. You can specify when you run a node which history mode you want, and you can switch with some constraints between modes. For instance, if you have started your node as an archive mode, you have all the information of the chain, and you can easily switch to full or rolling mode at any time by removing some of the information. But of course, if you are in rolling mode and you only know the recent state of the chain, you cannot go back to archive mode because you cannot reconstruct the data you don't have. But you can still find a snapshot for archive and restart a node in archive mode. Another thing that you can do if you run your node, so you have your own node, you may want to monitor it. We provide some metrics that the Octez node can produce if you use this dash metrics option. And those metrics will give you some information about what happens in the node. There are a lot of metrics. We won't go into details. Again, look at the documentation. But you can find some information about, for example, the number of active connections of your node, the number of RPC calls that are done to your node. So you can check if your application is requesting making too many calls to the node or things like that. You can even look at what happens in the chain. For example, look at the gas consumed in each block. So you have a lot of information regarding the node and regarding the global network, what happens into Tezos. And once you have started to produce metrics, it's very easy to use any tool to query those metrics and get information about it. If you want, we also provide Graphazos that are Grafana dashboards using those metrics. And with them, you can benefit from Grafana that will collect all those metrics and arrange those nice dashboards and allow you to look at what happens in real time and what happened in the past to your node. So we've looked at the node. Let's look at the Tezos client. So Tezos client is a CLI client for Tezos. It can interact with the node. It can, for example, query the status of the node and ask it to perform some actions. To do so, it uses RPCs. We will see that. For example, you can use the very simple bootstrap command to ask the node if it has synchronized and wait for an answer until the synchronization is finished. So it has a lot of commands that are described in the documentation again. But it's also a simple wallet. If you want, you can use it to generate accounts and then to do some transfers using the Tezos client. Of course, it's a CLI wallet, and if you prefer to use a graphical wallet, we also develop, as I said before, Umami, which is a powerful graphical desktop wallet for Tezos. So as I said, the client is only using RPCs to interact with the node. It can be interesting for you to know that there is an option, the log request option, that exists. With this option, you can use a command of the client and see all the actual RPC calls that are done by the client. And if you want to build an application that has to interact with a node, it can be interesting for you to do this, to mimic the behavior of the client in your application. Just for information, for example, to do a simple transfer, the Tezos client calls more than 20 RPCs, and it's just the transfer command in the client. So probably that's interesting to look at this option if you want to interact with the node. Having RPCs open to the network can be dangerous. So we provide access control list to make sure that you do not open all the RPCs to everyone. By default, only some RPCs are accessible locally, and only the safe ones are accessible remotely. But you can specify this in more details using whitelist and blacklist to specify which address can access to which RPC in your node. Of course, using this, you can also open all your RPCs to the network, and we encourage you to not do that. That's very dangerous. It can put your node in danger of many different attacks. So use the default policy or change it, but be aware this can be dangerous to your node. So we have seen the client, and as I said, it needs a node running to work correctly. As I said just before, some RPCs can be more dangerous than others, and also some RPCs can trigger some very long computation on the node part. This is in general okay if you're running your own node and you have only one client communicating with the node, but this can become an issue if you have many clients that are connected to a node. If you have many clients that serve one single node that serves too many clients, it can start to slow down, and the answers may take longer. So we provide few modes for the client to help you, in particular for testing purposes. So first, we provide what we call the mockup client. The mockup client is a very special client that runs all its computation locally without being connected to a node. So this means that when you use the mockup client, you can simulate a connection to a node and have very fast interaction with your client. But of course, you cannot use all the RPCs, all the commands of the client, because for some of them, you have to know the actual state of the ledger and communicate with a node. Still, it's very powerful, in fact, because you can simulate some transactions, you can originate a contract, you can call the contract, so you can already do a lot of testing in the mockup client. To go a bit further, we provide what we call the proxy client. Proxy client is similar to the mockup client. It does most of its computation locally, but it can communicate with the node to get the information needed for better results. So that's a bit slower for these communication than the mockup client, but it's still way faster than using a client, the normal client connected to a node. Of course, node administrators can automatically redirect the queries they receive to proxy client to avoid being saturated and improve their performance. We also provide the light client. The light client is similar to the proxy client, but for more security, it obtains its data from multiple endpoints in order to avoid the risk of being connected to only one node that is compromised. So it will get the information from multiple nodes. For the rest, it's similar. To ease the use of the proxy client and make it even more efficient, we developed the proxy server. The proxy server is similar to the proxy client. It does all its computation locally without connecting to a node, except for to fetch some data. But for more performance, it has a direct access in read-only mode to the data from the node. So it's more performant than the proxy client, but you need to have access locally to the node to be able to run the proxy server. In fact, proxy server is a solution we are working on to help public node providers redirect all their queries to those clients, to those servers, for more performance. And this is the kind of network we should have in the future with proxy servers. Of course, mockup client, proxy client, light client, and proxy server are all part of Octez. And if you use them or if you want them to have more specific options, please come to us, tell us what you need, and we will try to continue improving this. So we've seen the node, we've seen the client, but there is also the baker. So the baker is the daemon that executes the Tezos consensus algorithm. It's used to bake blocks, so to produce the blocks by selecting some transactions from the mempool of a node and arranging them into a block. It also emits consensus operations like endorsement. And to do so, it needs to have the necessary rights. And to have the necessary rights, it needs to be associated to an account with stake. So you have to have some stake in the network to be able to run a baker and have it bake some blocks. The baker needs a node to run. It needs to be synchronized to a node, and in fact, it needs to be locally connected to a node because for more performance, like the proxy server, it needs to have access in read-only to the data of the node. Bakers can include the operation from this node, of course, from the mempool of the node, but they can also fetch operations from a file, and this can be interesting for you if you want to emit operation into the chain without emitting them into the network before, and making sure that only your baker that will include them in the network. So for more information, again, documentation, manual. So why would you need to bake by yourself? So bakers are very important actors into the network. They produce the block, they actively participate in the consensus algorithm, they are rewarded for this by newly minted tokens. They receive also the fees from the operations they include. But in fact, the operations emitted on the network can be included by any baker. So if you just want to emit an operation, you probably don't need a baker. It's also possible to delegate your stake to a baker, and it will increase its staking power, its chances of baking a block, and it will increase probably its rewards. But the delegates may share their rewards with their delegators, so probably you don't need a baker for most of things. In particular, you don't need a baker to emit a transaction into the network. Well, you need one, but you don't need to run your own baker. You don't need to run your own baker to originate or to call smart contracts. You don't need it to stake your tokens and probably to receive rewards. So why would you need to run your own baker? Again, to mitigate some risks. First, if you want to ensure the inclusion of your operation, as I said before, when you include an operation, when you emit an operation, it will be propagated in the network, but who knows, maybe a baker will include it, maybe not. So if you want to make sure it's included in the network, probably you have to run your own baker. It's useful also if you want to reduce the fees. As I said, the baker will keep the fees of the operation that includes. So if you run your own baker, you don't have to pay the fees for your own operations. Again, it's very important to improve the decentralization and the health of the network to have many bakers, so we encourage you to run your own baker. That said, if operation inclusion rate is critical for you, having your own baker may be an issue because you may need to have a lot of stake to make sure that you will bake blocks very frequently. So probably if inclusion rate is critical, you probably will prefer to emit operations in the network directly. If you want more information and check how to run your own baker, we have a very recent tutorial about that. So, as I said before, Octez is mostly consisting of tools to run the overall infrastructure, the layer 1, but we also have a few developer tools in Octez. In particular, you can find things like Remote Signer, but you can also find testing frameworks, mostly used by core developers, but you can look at them if you want to test applications and their interaction with nodes and bakers. And we also have a very specific tool that I wanted to mention today, which is Tezos Codec. So Tezos Codec is an executable that can describe, encode, and decode data from binary to JSON in the format for the data structures that are used in Tezos. So I won't go into details again. There is a very nice documentation for that. But if you are building an application that has to interact with the network by exchanging some data, look at Tezos Codec. It will probably be a very good help for you. So that's it for me. Thank you.
Hello, thank you very much for this presentation. And it was regarding testnets with the introduction of ghostnets. Is it are the Jakarta.net, Kathmandu.net going to disappear, and are you is only going to stay the ghostnet because it's following the upgrade? I mean, the other testnets, what would be the use in the future if there is the ghostnet?
Okay, so
first question, and second question, just out of curiosity, what would be the name of the next upgrade, the L upgrade?
So, the second question is easy. We don't know the name yet. But for the first question, no, we don't plan to stop the other networks. Of course, GhostNet, we will see how GhostNet lives and if a lot of people are using it and what happens with the other network, but it's not, we don't plan to stop them for now. Yeah.
Thank you. Very, very, very informative very informative one. I have a question. I have a bunch of questions, but I would like to stop on the security. Maybe it deserves some specific dedicated talk. But like to keep it short, you few times you mentioned compromised node, right?
Yeah.
So could you please explain more about vectors, security vectors attacks that can be done by malicious compromised node? And then the follow-up, whose responsibility to observe these attacks, right? If it's the decentralized network, and who has either the rights or, yeah, let's say, who has the power to kick out that node, if it's possible even?
Okay. So first, the first part of the question, what is a compromised node and what can happen with a compromised node? It depends. I don't know. Anything can happen to the node if it's compromised. So to the network, probably not much. So nodes have some security parts to make sure that if they receive some data that they cannot understand or things like that, they will kick the other node. That's the automatic security part. But of course, if the compromised node behaves exactly like a normal node, why did it behave like a normal node? There's no reason to kick it. And after that, it depends. I mean, you can probably imagine. I mean, the main issue with the compromised node for you is if you are connected to this node directly and want to use it to emit your operation. The network should be safe.
If I run some compromised node,
yeah.
I'm on a malicious node. I injected some code that can be harmful to them.
No, it should not. I mean, no, if all the network is compromised, then the network is compromised. I mean, but if you only have one node or a few nodes in the network that are malicious, no, then the network should be safe. Yeah. So some DApps are directly connecting to a wallet to emit operations, and are using the wallet. But you can also interact directly with a node if you prefer, and be considered as a client. Yeah.
Two questions. My second question is yes. My second question. Sorry. My second question. I want to know a DApp communicate with node or client?
They can do both. They can communicate directly to a node via RPCs, but they can go through the client to communicate, to do the communication with the node. But yeah.
Thank you very much.
Yeah.
Hey, thank you for a great talk. For the Tezos client markup mode, is the interface via the Tezos client's command line interface? And is there or will there be plans to have markup mode exposed as RPCs?
Currently, I think it's still the interface of the node, of the client. I mean, directly. But yeah, it would make sense. We could check this. Yeah. Okay.
Anyone else?
I have a little question about Yes Node. I saw mentioned somewhere.
The Yes Node?
Yes.
Okay, so the Yes Node is used only for testing, so that's a node that is changed to accept any operations. I don't know what I can say about that except that, but we have Yes Nodes in our test suite, but of course not in the network.
Okay. All right, and with that, let's give a nice round of applause. And thank you for presenting.